We're really happy to have Lisa Busch joining us from the Sitka Sound Science Center. And you've probably heard that they've done some great work with a landslide warning system there. Seemed like a good time to start having this conversation in Petersburg. So she's going to give us a talk tonight, and she's also going to be here for a conversation tomorrow from 11 to 12:30 in this room. We'll see if there's interest and talk about what it might actually take to make that happen here in Petersburg. So give a warm welcome to Lisa, please. Thank you, Lisa.
Well, I just want to start by saying thank you so much for inviting me. I am really honored to be here in Petersburg. Again, my name is Lisa Busch, and I'm the executive director of the Sitka Sound Science Center. And what I wanted to do today is share our story of what our community did with lots and lots of partners to create a landslide warning system that's tailored to our community. And I'm really here to just kind of wet your whistle and share what we've learned and see, sort of where it goes from there. Okay, now I have to find the mouse. It's all good. Okay, so a little, just tiny bit about me, just so you know where I'm coming from. I've been in Sitka for 37 years. I came here as a public radio reporter, and I worked as a public radio reporter for a couple of years, and then I quit and was a science reporter for most of my career. I did major in geology, but I did the world of geology a favor, and I did not stay in the world of geology. Anyway, I helped as a community member in Sitka. I helped start another nonprofit and kind of learned how to build constituencies, and that was Sitka Trail Works. And then my friends were working at Sheldon Jackson College when it shut down very suddenly, and they didn't know what to do. And so they started another nonprofit, and they recruited me with an old building. And I've been working there for the last 14 years. So what is the Sitka Sound Science Center? We are a nonprofit, and our mission is science research and science education. We have a robust portfolio of research that reflects the interests and needs of the community and the region, and that includes things like landslides, because that's something that we're interested in, not just in Sitka, but in other communities. It also includes ocean acidification and kelp forest and salmon genetics and marine geology. And then on the education side of what we do, we have over 30 education programs, preschool programs, in-school programs, out-of-school programs, summer camps, internships, programs with undergraduate institutions. But our special sauce, I think, as a field station, is we put a lot of emphasis on community engagement. So we facilitate conversations between researchers and community members. So researchers can find out what people in Southeast Alaska are really interested in knowing, and the people who live here can find out what scientists are learning about our area. So that's kind of something that's going to come into play a little later on when we talk about the development of this. Come on. Okay, so our community, very much like Petersburg, we're reliant on fishing. We have we have a huge tourism industry now that we're grappling with. We have, the large regional hospital. The Tlingit people are have been in Sitka since time immemorial, very likely witnessed the last ice age. And like you here in Petersburg, we in Sitka live very closely to the land, to our natural world, and rely on the land and the ocean for our living, for our spiritual sustenance, and for our culture. So if you look at the landscape of Sitka, we have very steep mountains. We have over 100 inches of rain a year. And it seems obvious now that we would have landslides. But until 2015, honestly, we did not think about landslides as a community. I don't know about you guys, but we worried mostly about tsunamis and earthquakes and things like that. Well, in 2015, we had a deadly landslide, debris flow that killed our beloved friends and our community members, destroyed homes and properties all over the city. And quite frankly, we were surprised. We were just plain flat-footed surprised. And of course, as a community like Wrangell is going through now, we were grief-stricken. All of a sudden, so we were we were grief-stricken about the loss of our community members, but also a bit of naivete was gone. So as you know, because we're all Southeast Alaskans here, the rain makes it so special here. The rain makes the salmon, great and strong. The rain is important to the healthy forest. We do everything in the rain. And now all of a sudden, after this landslide, we were afraid of the rain as a community. People were questioning, should we send our children to school? Are the schools in landslide zones? And that sort of thing. And there was a tremendous amount of anxiety, just kind of low-level anxiety. So what we did as a science center is we reached out to the scientific community, and we reached out to agencies, federal agencies, state agencies, academic institutions from all over the country. We had our local experts we had our local experts in Sitka. Jackie Foss, who is with me now, she works for the Forest Service. She's a soil scientist. She was on the scene immediately, but as a community, Sitka doesn't have a soil scientist on the payroll kind of thing working for the city, and so we really didn't have a lot of local landslide experts. So we called the U.S. Geologic Survey, we called the National Park Service, the U.S. Forest Service, the National Weather Service, places like University of Oregon, where they're famous for their landslide researchers. And we said, can you help us? And to the scientists' credit and the agency's credit and the state's credit, they said, yes, we want to help. And so this was sort of before the Zoom world happened. So we met a lot on the telephone. There was a group of about 35 people. We met weekly, then we moved to monthly. And about a year and a half in, the city of Sitka helped us gather all these experts together and bring them to Sitka. And what we said to these experts is, what scientific questions can you answer that will make us feel less anxious? And the scientists were very good. They were like, well, if we knew more about the geology and the topography of the area, if we knew how much rain was going to fall, if we knew how much rain had fallen, how much moisture there was in the soil, how much pore pressure and things like that there were in the soil, we could start to make a model that could predict landslides. And we were very excited about that. We'd never heard of that before. We didn't know of any other place that was doing it. Well, it turns out other places were doing it. I have come to find out we're kind of late in the game, actually, in landslide prediction. But at the time, there was a place north of a railroad, north of Seattle, that is very worried about its railroad. And so they have a landslide warning system that's a privately run landslide warning system. And then San Bernardino County, where there's been lots of wildfires, there's lots of mudslides, they work with the U.S. Geologic Survey to develop a landslide warning system. So those were two sort of major ones in the country. Okay, so then we started to do what we do at the Science Center. So we started to set up this sort of two-way conversation between the scientific community and the community. And we put scientists on the radio. We brought them to the Sitka Tribe of Alaska meetings, the city council meetings. We brought them into the schools. And we started this conversation about potentially having a landslide warning system, but also just kind of explaining for the very beginning, explaining what goes into landslides. So I am, again, not a geologist. I have Jackie here to kind of validate or verify and ask, if you want to ask technical geology questions when I'm done, she's going to be better at answering those. But essentially, there's a few things that go into landslides, and these are debris flows. So these are considered shallow landslides. You need a steep slope. You need a bunch of material on top of that slope. So that could be soil, that could be rocks, that could be trees. And then sometimes one of the ingredients is undercutting at the bottom of the slope, right? That kind of makes sense to people. So there might be a road, there might have been logging, there might have been other things that undercut the toe or the very bottom of the hillside. And then the other thing is pore pressure. So what is pore pressure? Pore pressure is basically the pressure in soil that is between the grains, in between the sediment particles. It's kind of like when you dive down in the ocean and you dive really deep in the ocean, there's pressure all around you. And it's very much true. That's very much true when the soil gets saturated with water. The grains in the soil experience pressure that essentially push them apart. And pore pressure is increased when water is added to the ground faster than it can drain away into rivers. So that pore pressure can be increased when there's an impermeable layer somewhere in, a few feet down. It might be a few feet down, it might be more than a few feet down. But in our neck of the woods in Sitka, we have an ash layer. In other places, there's another kind of an impermeable layer of, could be rock or soil. And that pushes that means that the water can't drain down through the soil, right? So the water has no place to go, and it's increasing the pressure on the sediment. Does that make sense? Yes. In the dark here, literally. So water is a really big part of landslides in our area. So the other things that go into landslides generally happen over geologic time, right? The steepness of a mountain, how much material is on a hillside, those kinds of things happen over huge amounts of time. But rain, as we know in Southeast Alaska, can happen in a matter of, it can supersaturate a soil in a matter of hours, right? You could have a big rainstorm that can increase pore pressure in a couple of days. And heavy rain almost always characterizes when Southeast Alaska landslides happen. So the recent tragedy in Wrangell, the deadly slides in Sitka and in Haines, they happened during strong rainstorms. And shallow seated landslides were triggered by these short bursts of intense rain over a few hours. And what the climate scientists tell us is that we're experiencing rapid environmental change. We're experiencing climate change, and that entails more intensity to our atmospheric rivers, which are these, we used to call them the Pineapple Express. And this air that comes in sort of river-like forms over from the South Pacific over Southeast Alaska, and it hits the coast with a lot of short bursts of rain, more intense bursts of rain. So if you're a regular listener to the National Weather Service, you'll probably hear more and more often, you probably have already heard, their forecasting of atmospheric rivers. And this is what they're talking about. Okay, so what we did was after we sort of started this public discussion, the scientists first wanted to figure out where would landslides happen in the Sitka area, and that required maps. And what we did not know at the time, and I know now, and I sing it widely to all Southeast Alaska communities, is the Forest Service keeps a landslide inventory. And Jackie Foss, who's here tonight, she was a big part of keeping that inventory for a long time, so she knows a lot of details about it. And so we looked at that inventory. We looked at another mapping project that the Forest Service did. They contracted with Terrain Works to map our area. And the state of Alaska, the department, or is the DGGS, which is the Division of Geology and Geophysical Services, also had done a mapping project, right? Because they were interested in how landslides might affect roads in our area. And then a couple of academics had done some landslide work. And then the city of Sitka had done some mapping because they wanted to be sure our schools were, they were really, really specific about where they wanted to do the mapping, and it was above our schools and some other public service buildings and that sort of thing. So this mapping part was a big part of the or kind of an early part of the project. So yeah, this is just to show you that this is kind of a one idea behind the landslide inventory, but there's lots and lots of maps related to the U.S. Forest Service landslide inventory. Another thing that we needed to do was correlate landslides and rainfall, because we know rainfall has something to do with landslides. So what we did was we looked at rainfall data from the Federal Aviation Administration. The FAA keeps track of rain at the airport. And then we thought we correlated that with what landslides had happened. So what was the rain intensity that happened when these 5 landslides in the past had happened? And we could make that connection. And then we also thought we could collect more rain data. And so we asked citizens in the community if we could put rain gauges, we call them tipping buckets, in their backyard. And we set up kind of a citizen science project. And those rain gauges go to the National Weather Service, and they help them with predictions and forecasting. So we did that. And then we also installed soil moisture monitoring stations and continued to collect that data along with the U.S. Geologic Survey. We were actually, at this point, we were funded by the National Science Foundation. And our funding was about if we could come up with a cheap soil moisture sensor. Long story short, no, we couldn't. So we used the U.S. Geologic Survey soil moisture sensors, and we set those up around town as well. The other thing we did, this wasn't all geoscience. The other thing that we did was we collected traditional knowledge, and we asked indigenous people and members of the Sitka tribe of Alaska to share their stories about landslides and land movement. And a lot of what we found was that most of the time in history, Alaska Native people were living close to their food source. So they were living close to the ocean and on the beach. They didn't really build their homes up in the mountains. And so they weren't really affected by landslides that way. They were affected, and stories showed that they were affected by flooding, and they would have to quickly move their villages and things like that. But landslides wasn't such a big part of traditional knowledge. The other thing we discovered was that we were working towards developing a landslide warning system that would be equitably distributed to the whole community. And I mean, I went into this, you know, I definitely admit I went into this with my own very basic assumptions. And I thought, well, that's easy. I mean, I know how I get my information, public radio, the newspaper. Well, we did with social scientists from the Ranch Corporation, we surveyed people. How do you get information? How do you spread information? If there's a tsunami warning or an earthquake or something, what do you do with that information? Do you call someone? Do you call your neighbor? Do you go over to your neighbor's house? Do you talk to people? And what we created was this web, and we kind of figured out that there's kind of 50 super spreaders in 50 or so super spreaders of information in the community. And we, you know, understood that that's an important resource for spreading information and getting information out to the community, especially when it came to things like conserving people's lives and saving people's lives. Something else that came up in the course of this work, and we weren't funded for originally, was insurance. So we went into this with, could we come up with a landslide warning system? We can't stop landslides, but could we save lives? And so we went into this thinking, we really want to save people's lives. And what people said throughout the course of this research and this work was, we're also concerned about our property. And what is all this research going to do to our property? And what is the knowledge of landslides in our neighborhoods or in our house, for our houses? What is that going to do to property values and insurance? So we brought in insurance experts, and they came in and they studied this topic. And then basically they kind of debunked some myths. So one myth that was floating around town was you couldn't get a mortgage anymore. Well, that wasn't true. You can still get a mortgage. And then one myth that was going around was you can't get landslide insurance. Well, no one in Alaska can get landslide insurance. It's not available. And so then the next question is, well, what do we do if we can't get landslide insurance, and we're thinking that more homes are in landslide areas? What do we do about that? So these landslide researchers created a white paper, and we held a workshop, and we invited to the workshop everyone involved in real estate. So we invited real estate agents, assessors, appraisers, the planning office from Juneau came, the state commissioner of insurance came, and we talked about what potentially could we do. So one of the recommendations was you could require the insurance companies to cover landslide insurance in Alaska. And the commissioner of insurance said the insurance companies will leave Alaska if we do that. And the insurance underwriters and insurance agents were at our workshop, and they agreed. That's not very likely. So what else could we do? Could we form some kind of cooperative, maybe between communities, where we would create a pool, or could we, kind of like they do for wooden boats, or could we create a neighborhood cooperative for insurance? We didn't solve that problem, but we brought in the city planners and city administrator and people like that, and I feel like it calmed them down a little bit about the work. Like I said, we didn't solve the problem, so that's still out there. And I was just at a big landslide conference, and I mentioned this, and hands went up right away. What did you find out about insurance? We need that too. So it's a worldwide issue. It's not just here in Southeast Alaska. So again, throughout the whole process, community engagement was central. So we would hold workshops where we would invite people in and ask them about their feelings about risk, and how do they want to be warned, and what do they think about this warning system. And that really happens slowly. As we all know, living in small towns in Southeast Alaska, it really depends on trusted relationships, and that takes time. And that's something, I've learned from being here for many years, and I'm sure most of you understand implicitly. And again, this was an iterative process. So we had to remain flexible in going into all this. We felt like, we'd never been here before. The Science Center wasn't the leaders because we didn't really know how this was going to go, but we were the conveners and the facilitators. And another assumption, and I admit I made this assumption, but lots of scientists did too. They said, oh, you guys already have a tsunami warning system. Why don't we just use that when we're going to warn people if the risk of landslides is high? And we asked people, and they said, absolutely not. We won't know if we should go uphill because it's a tsunami warning or downhill because it's a landslide warning. So we had to really rethink that. And this was at the time COVID was big, and remember how we were all watching dashboards online for COVID, and how many cases and how many people had been vaccinated and that sort of thing. And so people in our community said that's what they wanted for landslides. They wanted to go someplace and see the information. Plus, we're Alaskans, and we needed this landslide warning system to reflect Alaskan values and our community's values, which for Sitka, that might be different from Petersburg, but our community was very adamant. They did not want people to tell them what to do. They did not want the government to tell them to leave their homes. And our local government was, this is a brand new thing. So the local government didn't want to be the ones pressing a button telling people to leave their houses. Didn't have that much confidence in the system. So they didn't want to be part of that either. But this feeling like I want to assess the risk myself and make my own decisions about what I'm going to do with that information was really, really important in designing our landslide warning system. So if you go on your phone to Sitka Landslide or sitkalandslides.org, you can see our web app. And it essentially will tell you if there is a low, medium, or high risk of landslides right now. And our model right now is based on a 3-hour rain intensity from the rain gauge that we get from the airport. And since we've started this system, we've gone up to medium twice. And one time there was a landslide very close to a home. And the other time there was a giant landslide that was south of town. So it wasn't in the community, but it was south of the community. And something interesting that came up during the landslide workshops and when we were asking people, sort of what's your feel of risk? And one of the things we asked them is if we warn you of landslides and and we say there's a high risk of landslides and there is a landslide, but there's no people around, do you consider that a success? And a lot of people told us no, that the landslide has to be, sort of in a neighborhood, or it has to, be close to town. So I thought that was interesting. But anyway, so we have this now, and people can go to it and they can make their own decisions and they can drill down. There's lots of information on here. So you can, click on different buttons and get what I should pack if I'm going to leave my home and that sort of thing, all kinds of information. And something that I think is very important about this is we have a high degree of confidence when the landslide warning system is low. So that alone, I feel like, eases people's anxiety. So now every time it rains, you don't have to be so concerned. You can say, oh, it's low. We don't have the high risk of landslides every single time it rains. It's really, for our model anyway, it's based on an intensity of rain. Does that make sense? Yes. I can't see anybody. Very disconcerting. Okay. So something, I just wanted to show this picture. This is Sitka. These are the mountains behind Sitka. And I think one of the things that was important to the city of Sitka was we don't have a place, and when we have a tsunami warning, we all go to the high school, which is uphill. But we don't have a place for everyone in the community to go to downhill. And the city fire chief was very concerned about that. He didn't want the whole town evacuating and coming to the Centennial Building or the downtown main building. And one of the things we learned from our mapping is that the whole town is not in a high-risk landslide area. So that is also another thing that that is helpful to people. They can go on the landslide app. We have a map, and they can look at that map and see sort of generally, is my neighborhood in a high-risk area? So I wanted to, we've been working on this, really since 2015. And we're not the experts by any stretch of the imagination, but we have learned a few things about sort of general steps that could be taken to develop a landslide warning system. And by that, I mean a community-based landslide warning system. So this is a landslide warning system that reflects your town, or in our case, Sitka, our town. And that is really checking in with the community. is there an interest? Is there a will? Is this something that you want? And of course, I mean, Petersburg's like Sitka. You can't get everyone to agree on anything, you know, but generally, is it something that the community wants? And then going out and gathering existing data. So what data is already out there? What maps exist? What rainfall exists? What stream data exists? What agencies are involved? And then the next step is sort of finding, and from after that initial gathering of data, finding where are the gaps? What information do we need more of? Do we need more mapping? Do we need more rain data? That kind of thing. And then creating a predictive forecasting model. And I got to say, like, because I'm not a modeler and I'm not a forecaster, this was like, it seems like a giant step. And all of a sudden you just create a predictive model. But there are, I mean, our model is certainly published and it's out there, and we are, of course, happy to share it. And there's other models. And there are people who do this work. So it's not, I mean, it's a specialty, but it's not totally out there. And then also thinking about how you're going to strategically disseminate this information. Is this something you want a web app for, or do you just want more information and you give that information to the National Weather Service? That's, you know, really comes from creating this community, constant community feedback and figuring out different ways to check in with the community. And for us, that meant inviting specific organizations and specific people to come and sit down with us. We couldn't just, you know, throw it out there and say, come to a meeting. We had to, you know, specifically invite the superintendent of schools, specifically invite the head of the hospital, specifically invite the tribe, or go to the tribe meetings and things like that. And so to me, that was very, very important part of the project. And then also kind of my last message to you is that you are not alone. And I think I felt, and we all felt this way in Sitka. We live in this little town and we just have the mountains and all this rain, and we're on an island and we're all by ourselves, and who would even care, you know, if anything happened. And I just recently came back in November. I went to the World Landslide Science Forum in Florence, Italy. There were 1,200 people there representing 69 countries. And there was a big section just on community-based landslide systems. And they all had the same steps. They all had the same idea of, these are things where we need to reflect our community values and work with community partners. And speaking of partners, we have had a lot of very, very important partners on this. Certainly the government, the U.S. Forest Service, the U.S. Geologic Survey, the City of Sitka, the National Weather Service, Sitka Tribe of Alaska. And now we have, you know, we were just putting the finishing touches on the Sitka landslide warning system. The deadly and tragic landslide in Haines happened. And so Haines called us and said, can we have what you have? And we went back to the National Science Foundation and we got a 5-year grant to work with 5 other communities in the region to work on landslide warning systems. And, you know, it does take a lot of different kinds of expertise and a lot of partners to make this kind of thing happen. But I would say, I mean, I can't speak for the agencies, right? I can't speak for the agencies, but what we're doing now is in March, we're holding a interagency working group on landslides in Southeast Alaska. And we've invited the federal, the state, and local agencies, but we've invited, you know, the Forest Service, the National Weather Service, the U.S. Geologic Survey, the state DGGS, and they've all been very enthusiastic about wanting to work together. So again, you know, we're not alone. We have these great partners, and very, very, very grateful for that. And with that, I will say how grateful I am to the scientists who have wanted to help us, to all the people in our community who are willing to give us their opinions and let us know practically how it can work. And it's not all peaches and cream. We're thinking a lot about how can we maintain the system over time, who should maintain it, do we have the workforce in smaller towns, do we have the technical expertise to keep this going. So like it's not the end of the story yet, But with that, I would be happy to answer questions. Thank you very much. The question was, how did we determine that some of the areas were not in landslide areas?
With a map. So there are several maps that exist that show places of high risk, and they tend to be steep areas. So we know what, like, we're observant people. We take into a lot of factors when we go boating, right? No one just like gets in the, well, okay, I shouldn't assume most people don't just get in their boats and go. You look at the weather, you make sure you have what you need, you look around, you don't just leave the harbor, you make sure you're not going to hit another boat, right? It's the same thing with landslides. So most landslides occur where it's steep. So if you live in a place that's flat and there's nothing steep around you, you don't really have a huge landslide risk. And so that's the same as Sitka. So there's some places that just are not at the base of something steep.
And that's the same in Petersburg.
And that's the same in Petersburg. And so there's a bunch of different tools that exist these days. The USGS and the Forest Service are investing heavily in something called LiDAR, which is basically a model of the Earth. And so that's a super intense survey that shows a lot about what the ground looks like under the trees, which is great because trees hide a lot. So with that as a tool, you can run a bunch of queries and models on that to find, you know, where the slope is cupped. And so where it collects water, water's heavy, that increases your landslide risk. Or it shows where it's steep, you know, not everything steep will fail. Not everything like moderate slope is completely safe either. So it's a mapping effort, and it's just looking around you a little bit. Yeah.
I just want to stop for a minute and reintroduce. This is Jackie Foss. She is a Tongass forest soil scientist and a program manager of lots of things at high level in the Tongass for the Forest Service. And she kept our landslide. Or do you still keep the landslide inventory?
I delegate that, but
Yeah.
yes.
Yeah.
So yeah, so your point about sharing information is a very, very good one. And that has been, so first of all, that information is really, really important because people who go hunting and people who go fishing in remote areas, they see things that we don't necessarily see. The reason that we knew about that landslide south of town is because they happened to have a king opener that day and a bunch of people were fishing in crawfish. So they knew the exact time that that happened. And that is such a crucial data point for understanding more about landslides, because we can look, the National Weather Service can use all of their modeling and all of their radar to identify and pinpoint that cell and that time when that landslide occurred, which helps us understand when we have weather that'll initiate a landslide. So it's really important. We have not determined the best tool for getting that information back from the public. There's a lot of, Sitka has a Facebook page where they share lots of information. So that's the first place we go to. The National Weather Service accepts information about landslides. They'll grab that and they'll share that out. There's Sitka landslide. And one thing that's been really a real step forward is the National Weather Service in some of their weather forecasts will talk about landslide risk in their forecasts. It's not always the first thing, but it's in some of their forecast discussion or some other places. They've started issuing flooding and landslide warnings and watches along when they have these weather events. So it won't be specific to Farragut or all these places where there's a few people, but they do, that is something to be looking for. Now that we're in this scary place where we're clued into landslides that affect our, friends and our loved ones. Yes, so the question is, does Mitkoff have LiDAR? And I think if you don't have it, it's imminent. So I think it was coming from Wrangell and it's connecting the cake piece to the Wrangell piece. So I think it's gonna fill in that gap. I don't have a date. I forgot to look it up, but we'll say soon, which means in the next year or so.
Well, one of the questions was, can you correlate landslides with wind events? And then the other one was,
Or small seismic event.
or a small seismic event. Yes.
Triggered other than
Yes, and certainly landslides have been triggered by seismic events. But wind is a very talked about topic, because a lot of local people say when the landslide happened in Sitka, Haines, I think Wrangell too, there was a lot of wind. And so we feel like there's a correlation. But what the scientists say, and the scientists are very open to this, they're open to hearing about it. They say, yes, there is a correlation, but there's not a causation. So right now, you know, when we get these big rain events, they come with wind. Often they come with wind, but is it the wind that is causing the landslides? Right now, the science says it's the rain that's causing the intensity of the rain. But that's not to say, you know, down the line, they'll make more of a causation relationship.
Like you